This video is on section 5.2 notes, the sine and cosine functions. So what we're going to be learning how to do is how to use the unit circle to evaluate sine and cosine. So first we're going to talk about a little review of sine and cosine. Sine is the trig function that is equal to the ratio of the side opposite of a given angle in a right triangle to the hypotenuse, and cosine is the trig function that is equal to the ratio of the side adjacent to a given angle in a right triangle to the hypotenuse. So if we take our unit circle here, this is a unit circle because it has a radius of 1. And we're going to start from this point right here that they've labeled as XY, and we're going to draw a line straight down to create a triangle, and this is going to be a right triangle because these two sides are perpendicular to each other. This hypotenuse right here, the side that's across from the right angle, is a length of 1 because it's a radius of the unit circle. Then since this point up here is labeled as x and y, then that means that this horizontal distance is a length of x, and this vertical distance right here is a length of y. And then they told you right here that this angle measurement is a measurement of alpha. And so if we were to find sine of alpha would be opposite over hypotenuse, which would be y. And cos would be adjacent over hypotenuse. Cos of alpha is adjacent over hypotenuse, which would just be x. So that means that on the unit circle, the x coordinate is the same as cos of angle alpha, and the y coordinate is the same as sine of angle alpha. So when you're looking at a unit circle like this, all of the x coordinates correspond to cos of the angle, all of the y coordinates correspond to sine of the angle. So for example, if we wanted to find the exact values of sine and cosine, we could look at the angle on the unit circle and find cos of the angle and sine of the angle. So cos of pi halves and sine of pi halves. Cos of pi halves is 0, sine of pi halves is 1. So cos is the x-coordinate, sine is the y-coordinate. For negative 720 degrees, I would typically find what's coterminal to that. Negative 720 degrees is not something that's just off the tip of my top of my head. So negative 720 plus a full circle plus another full circle. Negative 720 is the same thing as 0 degrees. So cos of negative 720 and sine of negative 720. To find that on my unit circle, I'm just going to look at 0 degrees. Cos of 0 degrees is 1, and sine of 0 degrees is 0. Negative 5 pi halves, I can add 2 pi to find a coterminal angle, or if you feel more comfortable with this one, we could count our pi halves and just go backwards. So negative 1 pi halves, negative 2 pi halves, negative 3 pi halves, negative 4 pi halves, negative 5 pi halves. So negative 5 pi halves is the same as 3 pi halves. And you get that if you do negative 5 halves and add 2 and then add 2 again. So add 2 full circles and you get 3 pi halves. Okay, so cos of negative 5 pi halves and sine of negative 5 pi halves. So cos is 0, sine is negative 1. Okay, so all of these ended up being quadrantal angles. That is angles where the terminal side lies on a quadrant line, so x-axis or y-axis, and that's what made all of these 0 or 1 or negative 1. They were a little bit easier to write. Now some of these are going to be not quadrantal angles, and so these are going to have some of those other ratios where we have 1/2 or root 2 over 2 or root 3 over 2. So one thing that is good to know about the unit circle that can help you as you start to memorize it, because eventually we want to not have to take out the unit circle and reference it every time we use it. We want to be able to have all of these numbers in our brains. One thing that is helpful to know is that 1/2 as a decimal is the smallest number. Root 2 over 2 as a decimal is the medium-sized number, or the middle number, and root 3 over 2 as a decimal is the largest number. And so when you compare them, you'll know smallest, middle, largest, and that can be helpful when you're working with the unit circle to know which ratio or which fraction you should be writing down as you evaluate these different numbers. So, and as we continue on through the notes, I'll talk about that a little bit more. So first we have sine of 135 degrees. Here's 135 degrees, it's right in the middle. Sine is the y-coordinate, and so the y-coordinate is root 2 over 2. Next, we have 2 times sine of negative 9 pi fourths. So for negative 9 pi fourths, I probably want to find an angle that is coterminal to that, or I could just count backwards. So I could say negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, 6/4, 7/4, 8/4, 9/4. So negative 9/4 is the same as 7 pi fourths. But I could also just add a full circle. So negative 9/4 plus a full circle. And you could say negative pi fourths, that's pretty comfortable, just go down 1/4. Or you could add another full circle and say, oh, that's 7 pi fourths. So I'm going to have 2. Sine of 7 pi fourths is negative root 2 over 2. Cos of 7 pi fourths is positive root 2 over 2. So negative root 2 over 2, positive root 2 over 2. This whole number 2 in the front is a fraction written over a 1. And so I'm going to go through and multiply this. Times 2 and divide by 2 cancel out. On the bottom I have a 2. 2 times 1 is just 2. Root 2 times root 2, the roots cancel out and you end up with a negative 2. Or you could say root 2 times root 2 is root 4, and root 4 is just 2. So negative 2 over 2 is negative 1. All right, cos 7 pi over 6. 7 pi over 6 is right here. Cos is the x-coordinate, so that's negative root 3 over 2. All right, for this one, we have cos squared. We have negative 240. Now here, this notation can often be confusing for students, so I'm going to rewrite this so you understand what it means. It means that you're taking cos of negative 240 degrees, and whatever result you have for that, you are squaring it. And then you're subtracting off sine of negative 240 degrees, whatever that is, squared. Okay, so cos of negative 240 degrees, if this is positive 240 degrees, then negative 240 degrees would be the same amount, just gone backwards. So negative 240 degrees would be this up here, positive 120. I can also just take negative 240 degrees and add a full circle to it to find the coterminal angle, 120 degrees. So cos of 120 is negative 1/2. So I have negative 1/2 squared. And then sine of 120 is √3/2. So this is going to be √3/2 squared. All right, when I square a fraction, I just multiply the top by itself and multiply the bottom by itself. So negative 1 times negative 1 is positive 1. 2 times 2 is 4. √3 times √3 is 3. Or you could say √3 times √3 is the square root of 9, which is 3. 2 times 2 is 4. And 1/4 minus 3/4 is negative 2/4, which is negative 1/2. All right, let's turn to the next page. Now, some people memorize the unit circle visually. Every time they use the unit circle, they would just like take a blank unit circle and fill it in, or they would draw a sketch of a unit circle on their paper and fill it in. And some people use reference angles. And they memorize the reference angles, which is kind of the idea that maybe you would just use the angles in the first quadrant. You would memorize these and kind of ignore the rest a little bit, and that would help you have the unit circle memorized and be able to evaluate any trig ratio that's on the unit circle. I kind of have a compromise between the two, and so that's kind of what I'm going to describe to you as we do these next 4 problems where we sketch reference angles and then write the information down. So whichever you decide to do, I'm not going to force you to do one or the other. If you have taken this class already in high school and you have a high school teacher who taught you a method that you really, really like, then go for that. That's totally fine with me. So it says, for each of the following angle measurements, draw a sketch of the reference angle and write the reference angle in both radians and degrees. Then find sine and cosine for each angle using the reference angle. So 120 degrees is right here. And the reference angle is always the angle that is made between this terminal side and the x-axis. Not the positive x-axis necessarily, it could be the negative x-axis. It's whichever way you can get to the x-axis the quickest. So this right here is the reference angle for a 120 degree angle. And this reference angle is actually a 60 degree angle. This is 60 degrees away from the x-axis. So I would say this is a 60 degree angle, which is pi thirds. And then from here, we can say what sine and cosine of this angle are. So sine of 120 and cosine of 120. And this is where we're going to go back and use what I told you guys about, where I said that 1/2 is the smallest decimal, √2/2 is the medium decimal, √3/2 is the big decimal. So right here, if we have this as an x coordinate and a y coordinate, to get to this x and y coordinate, we went left a little bit and up a lot. If we did this x and y coordinate, we would go left a medium amount and up a medium amount. If we did this x and y coordinate, we would do left a lot, up a little bit. So you can see that each of the points has different decimal values that it correlates to. We have a little bit, a medium amount, a lot. This is how I think of it visually. So here I went left a little bit, up a lot, which means that I went left 1/2 and I went up √3/2. Those are my ratios. And then I just have to think, here I went left, which means the 1/2 is negative. I went up √3/2, which means the 3/2 is positive. So sine is the y-coordinate, cos is the x-coordinate. So that's how I could use reference angles and do it visually to figure out my ratios for these two without taking a unit circle, finding 120, and locating the x and the y coordinate. Okay, here's the next one, 7 pi over 6. Right over here is 1 pi. This is 6/6. And so 1/6 further is right here. So this is where 7 pi over 6 is. And so this reference angle right here is pi over 6, or 30 degrees. So 6/6 is pi. This is 1/6 more, or 30 degrees. So to get to this x and y coordinate, I went left a lot and down a little bit. Left a lot and down a little bit. So the x coordinate is √3/2, that's the biggest number. The y coordinate is 1/2, that's the smallest number. Left a lot, down a little bit. Since I went left and down, both of those numbers are going to be negative. So sine of 7 pi over 6 and cos of 7 pi over 6. Sine is the y-coordinate, negative 1/2. Cos is the x-coordinate, negative √3/2. All right, 690 degrees. This one I'm going to find the coterminal angle. 330 degrees. So here, 270, 300, 330 is right here. So this is another 30-degree reference angle, which is pi over 6. And so to get to that x and y coordinate, we would have gone to the right a lot, down a little bit. So to the right a lot, down a little bit. So we have sine of 690, cos of 690. So sine is the y-coordinate. Cos is the x-coordinate. Okay, negative 7 pi fourths. So positive 7 pi fourths is right here. That's if they measured this way. There's positive 7 pi fourths. And so negative 7 pi fourths means that I measured backwards. And so that's right here. You could also say negative 7 fourths plus a whole circle is 1/4. So there's pi fourths. This is a 45-degree angle. And so right here we have that medium amount. We went to the right a medium amount. We went up a medium amount. And so this as an x and a y coordinate is √2/2, √2/2. So sine of negative 7 pi over 4, cos of negative 7 pi over 4. The x and the y coordinate are the same. They're both just √2/2. Now, if that method of memorizing the ratios is not helpful for you, you don't have to use that method. You are welcome to Google other methods. There's tons of methods online for memorizing the unit circle, but it's good if you don't have to get this out every single time. Eventually, I'll probably get to the point where on tests you're not allowed to use a filled out unit circle. If you're allowed to use one, I'll hand you a blank one. So keep that in mind as we go through the rest of this course, that eventually this needs to be in your head, especially those of you who are planning on taking calculus. By the time you get to calculus, this should be memorized. All right, now here it says to use a calculator to evaluate each of the following. And so it's important when you are evaluating something using a trig function that you put your calculator into radians or degrees. And the only time it really matters if your calculator is in radians or degrees is if you're actually going to press one of these trig buttons. So the sine, cos, or tan button, if you're actually going to press them, then it matters. If you're not pressing those buttons, it doesn't matter what mode you're in. So for this first problem, there's no bubble here. It just says 4.27. So since there's no degree bubble, I know that my calculator should be in radians. So I'm going to hit mode. I can see radians is dark, and so that means my calculator is currently in radians. So I can hit the sine button and type 4.27. So negative 0.904. And then here there is a degree bubble, so I need to convert into degrees, or put my calculator into degrees, I mean. So make sure it's highlighted on degrees and press enter. Now my calculator is in degrees, and then I can type cos, negative 39.46, 0.772. Sine and cosine functions bounce back and forth between -1 and +1, and so these answers will pretty much always be a decimal answer that's between -1 and +1. So do not stress if you have a weird answer for these, that is normal. All right. The fundamental identity of trigonometry is this: sine squared plus cos squared equals 1, and I'm going to show you where that comes from. We're just going to draw this triangle again that we drew in the beginning of our notes, where we drew this line down, and we said this is a right angle right here. And we said if this is the point xy, then this is the horizontal distance x, and this is the vertical distance y. And then because this is a unit circle and the radius of the unit circle is 1, that means the hypotenuse is 1. So now if we were to say, well, this is a right triangle, I can use the Pythagorean theorem on a right triangle. I would say x squared plus y squared equals 1 squared. And if I know that cos alpha is the same thing as x, then I can do a substitution here. I can take out the x, and I can rewrite this as cos alpha squared. Y is the same as sine alpha, so I can do a substitution there and say that y is sine alpha, and then squared, equals 1 squared. And then the shorthand way of writing this is just to say cos squared plus sine squared. That's not an alpha, that should be a 2. Cos squared plus sine squared equals 1 squared, or equals 1. And of course it doesn't matter when you're adding things together, you can switch the order. So cos squared plus sine squared equals 1 is the same thing as sine squared plus cos squared equals 1. So we have one last example. It says find cos of the angle given that the ratio of sine, opposite over hypotenuse, for some triangle that's drawn on these quadrants, 1, 2, 3, 4, that's drawn here, has an opposite over hypotenuse, has the sides of a triangle so that it's 3 over 5. The opposite side is a length of 3, the hypotenuse is a length of 5. And they said that the angle is in quadrant 2. So they're telling you that they drew the picture of this triangle in quadrant 2. So the nice thing here is that we don't have to draw pictures of this if we don't want to. We could draw pictures, but we don't have to. what we can do is use this fundamental identity up here, that cos of the angle squared plus sine of the angle squared equals 1. So I'm going to say cos alpha squared plus sine alpha squared equals 1. And so cos alpha squared, if I square this fraction, I get 3 squared, which is 9, over 5 squared, which is 25. That equals 1. To solve for this, I'm going to take 9 over 25 and subtract it to this side. So cos alpha squared, 1 minus 9/25, I could rewrite the 1 as 25/25. So 25 minus 9 is 16. So this is equal to 16/25. And then to solve for cos, I just need to square root both sides. And we know that whenever we take the square root of something, we always get plus minus. So I'm going to get plus minus. The square root of 16 is 4. The square root of 25 is 5. So I have two options for my ratio. I have positive 4/5 and negative 4/5. And cos alpha is the x-coordinate. So if my answer ends up in quadrant 1 or quadrant 4, my x-coordinate would be positive. If cos ends up in quadrant 2 or quadrant 3, my x-coordinate should be negative. So I know that cos is this ratio, and because my answer should be in quadrant 2, that tells me that I'm going to have a negative x-coordinate, or that cos is going to be negative there. So cos is negative 4/5. Here is another diagram that has the same information. It just tells you which of sine or cos is positive in which quadrant. So sine is positive in quadrants 1 and 2. Cos is positive in quadrants 1 and 4. So that's, you could read it this way if that's where you're comfortable reading the information, or you could think of it this way if this is how you're comfortable reading the information. So if you did not do the problem this way, the other way you could do the problem is by drawing a picture of a triangle and doing the Pythagorean theorem to find the missing side and solving it that way.